this video, we're going to look at simplifying rational expressions. This will be kind of short. I'm just going to show you 3 examples, but I want to emphasize a couple of things. Just a refresher, if you recall, if you divide anything by itself, it's equal to 1. So 3 divided by 3 is 1. If you had x divided by x, that's equal to 1. If you have x plus 1 divided by x plus 1, that's equal to 1. So anything divided by itself is 1. So if you have a ratio and you have two like factors, one in the denominator, one in the numerator, they will cancel out to equal 1. So that's one of the key things to keep in mind with simplifying rational expressions. The other key thing is that just to be careful, if you have something like x plus 3 over 3, those 3's do not cancel out because they are not like factors. A factor is something that is multiplied. And in this case, it's x plus 3. So we cannot simplify this any further than it is. No like factors will cancel out. Again, those 3 divided by 3, of course, is 1, but that's not what this meaning is. So just be careful there. However, if you saw 3x divided by 3, because that is multiplication, those 3's will cancel out, and you will get simply x. So note the difference between these. They have to be common factors to be able to cancel out. And some of you may be looking at this thinking, well, duh, of course I know that. But you'd be surprised, like it's really easy to, as you're working through a problem to just, quickly see that and want to cancel it out. So just word of caution, don't do that. It will not work mathematically. All right, so we're going to take this and expand this idea and expand it to rational functions, rational expressions where we have lots of different factors going on. So in this first example, this is already factored for you, so we can just kind of look at it and determine what cancels out. So again, like factors are multiplied. So what we have here is we have an x squared and an x. And if you take x squared and think of it as x times x divided by x, one of those will cancel out. So I'm going to change this and make it look like a x times x just so you can more easily see that x cancels with that x. And then also, actually let me use a different marker for this. So that x cancels with that x, and then we have an x plus 1 and an x plus 1 that will cancel. So what we do is we just cancel all the like factors and leave what's left. So we have an x still up there times an x plus 3, and everything in that denominator canceled. So this is what that simplified expression will be. So that's it. So simplifying is not hard. We do have to look at factoring. You have to be comfortable with factoring to be able to do this because this one was already in factored form. Sometimes it will not be, such as this one. So again, don't get tempted to say, oh, well, 2 goes into 4, they have a like factor. Nope, they're not multiplied. They're not common factors. We can't do that. So we need to put this in factored form before we can start to cancel out like factors. So if you recall, we're going to factor by looking at, in this case, the leading coefficient, and that is supposed to be a square. I'm writing too fast there. All right, so the leading coefficient is 1. So this will be an x times x equals that x squared. And then what do we multiply to be 2 and add up to be a negative 3? That would be a negative 2 and a negative 1. I did post a video on factoring, so if you need a refresher on how we're getting that, you can go back to that. And then down here, this is a difference of squares. So that factors to x plus 2 times x minus 2. And once you factor, then we can cancel out the like factors. Notice that you have 2 like factors, x minus 2 and x minus 1 are the 2 factors in the numerator, and x plus 2 and x minus 2 are the 2 factors in the denominator. We have an x minus 2 in each, so we can cancel those out. And what we're left with is the x minus 1 in the numerator and the x plus 2 in the denominator, and that's it. All right, I'm going to just draw a line here so we don't get this next one confused with those. All right, this one we need to factor as well. There's a little bit more going on. If you look at this as the product of 2 binomials, since it is a trinomial, we can certainly do it that way, but there also, I noticed that there is a GCF of 2. So remember, if there's a GCF, you always want to factor that out first. It'll make your overall factoring a lot easier, and in some cases it's not possible until you do that. All right, so we're going to factor out the 2. So we're going to have y squared minus 8y minus 20 over, and then I'm just going to rewrite this. I'll factor in the next step. All right, so I wanted to factor out that 2. That made this a lot easier to handle as far as factoring it. Is the quadratic trinomial, so I can factor it into the into the product of 2 binomials. So I'm going to go ahead and do that. I want to keep that 2 out there, but we know that this y squared minus 8y minus 20 is going to factor. So the first terms are going to multiply to be y squared, so I know it's going to be y and y. And the second 2 terms will multiply to be negative 20 and add up to be negative 8. And that will be a negative 10 and a positive 2. Will multiply to be negative 20 and add up to be negative 8. All right, and then in the denominator, I'm going to go ahead and factor this as well. So this is similar in that I'm looking for what multiplies to be y squared, so this can be y and y. And then what multiplies to be 12 and adds up to be 8. And that would be 6 and 2. So plus 6 and plus 2. And once we get to that point, you can see that we do have a common factor, that y plus 2 will cancel with this y plus 2, and we are left with 2 times y minus 10 in the numerator, and a y plus 6 in the denominator. For the purposes of just simplifying, once you get here and you've canceled out like factors, you do not need to go back and distribute that 2. There would be problems, like if we get down the road in solving, where you would want to distribute that 2 out, but for the purposes of these just simplifying problems, you do not necessarily have to do that. All right, so those are some examples on simplifying rational expressions.